Next the next topic to be discussed is parallel processing application, where all fields the parallel processing is done. The first one is predictive modeling and simulations, which include numeric weather prediction, oceanography and astrophysics, socio-economics and government use. And the second one is engineering design and automation, which include finite element analysis, artificial intelligence and automation, remote sensing applications. And the next is energy resources exploration, that is seismic exploration. Then medical, military and basic research. Here we have computer assisted tomography, genetic engineering, weapon research and defense, basic research problem. So first one is predictive modeling and simulation. That is, predictive modeling and simulations means in the case of atmospheric or earth environment or outer space, or in the case of world economy, high range of simulating experiments are needed. For that we require high speed computers. That is, the speed is approaching 1000 million megaflops or beyond. Okay, so in such situations we require the parallel processing high speed computers. Okay, so the multi-dimensional modeling of the atmosphere, the earth environment, outer space and the world economy has become a major concern for the world scientists. Okay, so the predictive modeling is done through extensive computer simulation experiments, which often involve large scale computations. Large scale computations are needed because then only we can acquire the high speed accuracy. Okay, the desired accuracy can be acquired and the turnaround time. So such modeling requires the state of the art computing speeds approaching 1000 million megaflops and beyond. So first one is numeric weather prediction. The numeric weather prediction or the numeric weather forecasting. This model uses the mathematical models of atmosphere and oceans. That is, weather model include short range calculations and large scale calculations. Short range calculations are needed in the case of temperature forecasting or rain forecasting, etc. Large scale calculations are needed in the case of natural range hazard predictions such as flood, drought, etc. Okay, so here we are using taking the current observations of the weather and processing this data with computer models. Okay, we are taking the present situation. Okay, and that is processed with some computer generated models. Then that is used to forecast the future state of the weather. For this we are using the method as data assimilation to produce output. What is data assimilation? It is a sequential stepping procedure in which the previous model is compared with newly received observations. Okay, to forecast the result. So previous model is compared with newly received observations. Okay, that is numeric weather predictions. Then the next one is oceanography and astrophysics. It is used to study the wealth of ocean using multiprocessors. Okay, in order to study the wealth of oceans using multiprocessors, that multiprocessor should have large computational power with low power requirements. That is, it is used to study the wealth of the ocean. Okay, so that type of computer should have large computing capacity but with less power consumption. Actually, we were used with ROMs, were used originally, but now MPI programming methods. MPI programming method is used message passing interface. MPI means message passing interface is used. That is, a MPI is a program or it is the interface used to create parallel processing programs. Okay, then computational astrophysics refers to the methods and computing tools developed in astrophysics and research. For that we are using some simulation models such as PIC. NPM and N-body simulations are the different important techniques used in computational astrophysics. Okay. Then the next one is socio-economics and government use. Large computers are in great demand in the areas of econometrics, social engineering, government census, crime control and the modeling of world economy. So here also we are using parallel processing for modeling of economy of the nation of a world. Okay, so program system which involve cluster computing device to implement parallel algorithms of scenario calculations, optimizations are used in such economic models. Such program system serves for conducting multi-scenario calculation to design a suitable development strategy for a region. So these are the predictive modeling and simulation examples. Okay, so next we have the engineering design and automation. Engineering design and automation is fast supercomputers have been in high demand for solving many engineering design problems such as the finite element analysis needed for structural design and wind tunnel experiments for aerodynamic studies. Industrial development also demands the use of computers to advance automation, artificial intelligence and remote sensing of earth resources. So engineering design means first we are simulating a model. For example, in order to before introducing a new aerodynamic device, we are first simulating it using the computer design. So for that things we require fast supercomputers. Okay, so that includes finite element analysis, FEA. It is the numeric method commonly used to solve the multi-physics problem. Then it is also used in the design of huge structures like ships, dams, supersonic jets, etc. So in FEA, extremely large amount of partial differential equations are to be solved concurrently and hence parallel processing elements are used. So in order to, before designing the huge structures like ship, dam, supersonic jet, etc., using the finite element analysis, we are designing a model using the high speed parallel processing elements. Okay. So the next one is artificial intelligence and automation. Artificial intelligence and automation, here we are using AI is the intelligence exhibited by machines or the software. So this AI requires large amount of parallel computing. So here we are using the artificial intelligence in image processing, expert system, natural language processing and pattern recognition. So the next we have remote sensing applications. So in remote sensing application, it is a software application that process remote sensing data. The remote sensing applications read the file formats that contain sensor image data, georeferencing information and sensor metadata. So this computer analysis of such remotely sensed earth resources data has many applications in agricultural, forestry, etc. So explosive amount of pictorial information needs to be processed in this area. Okay, so the next is energy resources exploration. The next category is energy resources exploration. Here the computers can play an important role in the discovery of oil and gas and the management and of their recovery, and also in the development of workable plasma fusion energy and in ensuring nuclear reactor safety. So we are using the computers in the newly high-speed computers are used in discovering oil and gas resources. Okay, then also in the development of plasma fusion energy and ensuring metal reactor with high safety. So using computers in energy area results in less production cost and higher safety measures. These areas, that is in the discovery and the recovery of oil and gas, and in the case of plasma fusion energy and a nuclear reactor, this all require high safety measures. Okay, So using high speed computers in this area help us to reduce the production cost and also to increase the safety. Then the fourth category is medical military basic research. In medical area, we are using the first computers in computer assisted tomography, that is a CAT scanning. Okay. Similarly, in artificial heart design, liver diagnosis, brain damage estimation and genetic engineering studies. Military defense need to use supercomputers for weapon design, effects simulation and other electronic warfare. Almost all basic areas demand fast computers to advance their studies. So these are the applications of parallel processing okay. These are the different applications. So let me conclude. It includes predictive modeling and simulation, in which we have discussed numerical weather forecasting, oceanography and astrophysics, and the last one is socioeconomics and government use. Then the second category we discussed is engineering design and automation, in which we have discussed finite element analysis, artificial intelligence and automation and remote sensing applications. And the third one is energy resources exploration. Okay, then the fourth one is medical, military and basic research. Okay, so this is all about the different applications of parallel processing. Okay.